Hi students, coming to the next topic, that is the information flow matrix. So far we have discussed about the functional point analysis and line of code. Now let us see the information flow matrix. So by Henry and Kafra, they are saying that they attempt to measure the complexity of code of measuring the flow of information from one procedure to another in terms of fans in and fans out. So these two persons are going calculated the flow of information from one procedure to another. So one procedure is sending information, another procedure is receiving, again that procedure is sending information, and this procedure is going to be received. So the attempts that is going to be measured, attempts or measured the complexity of code of measuring the flow of information from one procedure to another were calculated in terms of fan ins and fan outs. So how you are going to calculate the fan ins? Fan in means number of local flows into a procedure, means local flow direction. A message that will be passed inside exits if either a module invokes a second module, pass information to it, or invoked module returns to the result. So just like a passing information, that is you have to calculate the number of local flows into a procedure plus number of global structure, means it exists in if information flow from one module to another via global data structure. So the number of global structures read by procedure. So the fan in will be calculated the number of local flows in procedure. So in the procedure, how many flows are entering, means the input that we are entering plus the global structure you are reading by procedure, means the global structure we are reading from outside, from the user. So that calculates the fan in. And coming to the fan out is going to calculate the number of local flows from a procedure, means this is in means inside to the system, user system. So this is a in, number of local flows into a procedure, okay, plus number of global structure read by the procedure. And whereas fan out means number of local flows from procedure, from user to a system is nothing but here a procedure. The number of local flows from a procedure plus the global structures updated by the procedure, means after completion of the execution, the output is sent to the users. So along with the local flows of procedure, I need to calculate the number of global structures updated by the procedure. So this is a formula of calculating the flow in, means the method, the flow in and the flow out. Then how the flow represents, how the flow will be represented in the procedure. The information flow into a procedure via the argument list. So always the information flow will be taking place into the procedure via the argument list, means that the attributes you are using, the variables you are using, the functions that are using. So that indicates the information flow into a procedure. So the information flow into a procedure via the argument list, and the flows from the procedure due to return values of function calls. So always from the procedure means always the return values, to the procedure means argument list. So you have to, if you want to read the data, you need argument list. That is the information flow that we have taken from the user. Okay, if you want to execute, you have to return the value. You have to return the value that is from the procedure. You have to return. That is a function calls. That is the out. So F in, F out. So this is a flow representation. The main thing, the flow means it's just not a passing. It's just a variables that you are using while input and output, and the functions that you are using for inputting and outputting, that you call it as a flow. So here the flow representation for into the procedure of the argument list, and whereas the return values of function calls from the procedure is a flow represents. So thus the complexity of procedure P can be calculated as Cp. The complexity of procedure is equal to fan in into fan out square. So this is a formula of calculating the complexity of procedure. Thank you.